So we're ready to start looking at, in our current textbook, 14.2, multiplying and dividing rational expressions. So just a reminder on how we divide multiply and divide regular fractions. So let's take the fraction 3/5 and let's multiply it by 15 over 4. Well, all I do is I multiply the numerators and the denominators, and then I cancel any common factors. If I realize 15 is 3 times 5, then I can simply divide through by the 5s. Notice the 5 doesn't have to be straight above the other 5. These are 3 factors and they're multiplied. If I want it to be in the middle, I can rearrange it. So let's just rearrange it in our head to where it needs to be, So the end result at any rate is 3 times 3, which is 9, divided by 4. And they don't share any factors, so this is fully reduced. So let's now divide. Let's do 3/5 divided by 15/4. So what we do is we saw how easy it is to multiply something. If there was only some way I could change my division sign into a multiplication sign, and there is. The trick is I just write the first term exactly as it is, and then I magically write, instead of the division sign, multiplication sign. And the price I have to pay is I have to write the reciprocal of 15 divided by 4, which is 4 divided by 15. And then I just multiply across. 3 times 4 is 12. And 15 times 5 is, I'm pretty sure, 75. And there are no common factors. Are there? Yeah. Well, 12 is equal to 3 times 4, and 75 is equal to 3 times 25. So I can cancel out the 4, and the end result is 4/25, and that's fully reduced. So we're going to be doing the same thing, except instead of numbers, we're going to be looking at rational expressions. I'm going to give you one other example. What a unit fraction is. So here's just a definition, but definitions are important. Let x be any non-zero real number. So as soon as you hear a restriction placed on x that it can't be 0, think about division, because it's coming. Then 1 is equal to x divided by x, where x divided by x is a, and here's the word, unit fraction. Why is it a unit fraction? Because it's equal to 1. So that means x plus 5 divided by x plus 5 is also a unit fraction. So that means I can actually extend this definition to let x be any non-zero real number or polynomial. Then 1 is equal to x divided by x. And here x is probably a bad choice. I don't like using x to stand for polynomials like p or q2, but I just wanted to show you that it also works for polynomials, because those polynomials, unless you plug in a value for x for which they're 0, are just numerical values. So find each product and simplify if possible. So we're going to do multiplication first. Always hitting the wrong thing. So let's do example 1a. Let's see if I can get us some more room. There we go. So 1a. So I have 8p minus 8 divided by p times 7p squared over 9p minus 9. So the first thing I'm going to suggest you do is simplify anything you can. So clearly 8p minus p, I can pull out the greatest common factor, which is 8. That goes 8. That becomes 8 times p minus 1. It's still divided by p. Can't do anything there. 8's not prime, but it doesn't make any difference. P minus 1 is, and so is p. And I can't do anything with 8 and p because I don't know the value of p. This is multiplication. 7p squared, can't do anything with it just yet, but I am. And 9p minus 9, the greatest common factor is 9. So when I pull out my 9, I get p minus 1. Now let's see if we can cancel out anything. So p minus 1 is an entire factor, and it's found in both the numerator and the denominator. P squared is just p times p, and p times p divided by p gives me, that's p squared minus 1, it just gives me a p. So the end result, the only thing that I have left here, let me erase that and put what it actually is, it's just p after I've canceled it out, is 8 times 7, which is 56. 8 times 7 times p, so 8 times 7 is 56, and that times p is p. And on the bottom, all I have left down here, everything's been canceled out, that becomes a 1, so 1 times 9 is 9. And that's as far as it can be reduced, because 8 and 7 don't share any factors with 9. So now look at number B. We're not going to do number B because it has this weird, it requires the factorization of a cubic. We don't cover that in this class. And I actually do never use x plus 1 factors to that. It does indeed. You can multiply it out. It doesn't matter. We're not doing it. That you'll get to deal with the factorization of cubes in intermediate algebra. We're not going to do it in this class. So let's do 1c. So as you can see right here, we have a lot of degree 2 polynomials, and all of them are going to have to be factored. The good thing about all of these is that the leading term is 1. So they're a lot easier to factor, and many of you get good at factoring those type of polynomials. In your head. So I'm going to challenge you to pause right now and factor all 4 of those. I'm not going to do it for you. I'm done. We've done factorizations after factorizations after factorizations. You will get to see the final result. So x squared minus 11 plus 10. I hope you got that's x minus 1 times x minus 10. X squared minus 11x plus 28 is x minus 4 times x minus 7. X squared minus 9x plus 20 is x minus 4. X minus 5. And the last one, x squared minus 16x plus 60. X minus 10. X minus 6. So now we factor them, and what are we doing? We're looking for common factors in the numerator and denominator to cancel. We can start right here, so just look along the numerator line. That's all you have to do. Is there a factor of x minus 1 somewhere? There is not a factor of x minus 1 in the denominator. What about x minus 10? Yeah, there is. There's x minus 10. There's x minus 10. It's gone. What about an x minus 4? There is. X minus 4, x minus 4. And that's it. There is no x minus 5 down here. So now all I have to do is at the end process of this, you don't want to remultiply everything out. Keep them in their factored form. You did all of this work to factor them. Don't undo the work by multiplying them out. So the numerator is x minus 1 times x plus 5. Those are the two factors that survived. And the denominator is x minus 7 times x minus 10. Sorry, x minus 6. And that's all there is to that one. So now we're going to go into division, and we're going to use the trick that we've always used. The only thing I'm going to suggest here is for this first problem is that before you change the division sign into multiplication and multiply by the reciprocal of the second term, that you actually simplify each of those terms in the division first. It'll make it a lot easier. So I have minus 4k squared over 4k to the fifth. Now I'm dividing. But division really doesn't give us any problems because we can easily turn it into multiplication. Easy enough. So let's simplify this first term. So minus 4 divided by 4 is minus 1. I'm just going to write a minus up there. K squared divided by k to the fifth. Well, there's more factors of k in the bottom than on the top. How many? There's 3 more. So it's minus 1 times k divided by k cubed. I'm still doing division. 16 divided by 12, well, we can reduce that. 16 divided by 4 is 4. 12 divided by 4 is 3. And they clearly don't share any common factors. K to the fourth divided by k to the sixth. Well, the bottom term has 2 more factors of k than the top. So that's 3k squared. Now I'm ready to actually turn my division sign into a multiplication sign. So now I'm multiplying, and the end result is going to be minus 3/4 k squared divided by k cubed leaves 1k on the bottom, and that's it. Now let's do number B. Two minus 2x over x divided by 5x minus 5 over 3x squared. Well, again, I'm going to simplify before I change my division sign to a multiplication. So I'm going to pull out the greatest common factor, which is 2, over x. So now let's go ahead and let's divide it. So I'm going to change my division sign to a multiplication side and write the reciprocal of the second term in my division. Well, clearly Let's simplify some more. We're going to do some stuff with the 1 minus x and the x minus 1, but let's do that at the very end. So I'm going to write my division line down. 2/5 there, they cannot be reduced. And x squared divided by x leaves an x on top. Because there's 2 factors of x up here, only 1 there. This has 1 more than this one does, so it's x to the first power. And then I have my x minus 1. But notice if I have 1 minus x and x minus 1, that the 1's differ by sign and the x terms differ by sign. So I'm going to factor out a minus 1 to the x minus 1 term. So that's a minus x plus 1, which I'm going to write as 1 minus x minus 1 minus x. So I'm going to rechange this. The minus here is minus 1, so that minus is going to come out, because literally what I'm doing is multiplying 5 times minus 1 minus x. So that's how I'm going to get my minus 5, and all I have to do now is rearrange my terms, and I have yet one more factor that I can factor out. And the end result is equal to I'm going to put my negative out front, minus 2x divided by 5. Okay, one similar to what we did earlier, except it's division. So I'm going to write it down. And again, I want you to factor. This is 1, 2, 3, 4 polynomials. Just watching me do it doesn't help. This is where you get your practice, and once you see the exact answer, we're going to do something first to make the factorization easier. So these are polynomials in the variable k. Some of you might actually already want to start writing out simplifications or factorizations, especially when you see k squared minus 9. Let's just wait. So you see those leading terms and you think, ugh, it's not a 1. If it were a 1, I could do something. Well, you can do something. The first thing you should always do is factor out the GCF of every term. So if I look at the GCF of the 2k squared plus 8k plus 6, the GCF is 2. So 2k squared divided by 2 is k squared. 8k divided by 2 is 4k. And plus 6 divided by 2 is plus 3. Oh, that's going to be a lot easier to factor that. And I'm going to go ahead and factor my k squared minus 9 by realizing that's k squared minus 3 squared. And I hope that's, I didn't write squared, but I hope that's all you have to hear, and you can immediately write the factorization down. This is the difference of perfect squares factorization. So it's k minus 3, k plus 3. I'm not ready to divide yet. I think it's always easier to simplify anything you can simplify. And there isn't anything I can simplify on this first division term. But on the top polynomial here, I can factor out a 2. I cannot factor anything greater than a 2 because 14 is not evenly divisible by 4. So this will be the polynomial that might cause a little bit more work when you go to factor it. But it will still be easy if we factor out that 2. And down here, I can factor out a 2 from the 2k minus 6 and get 2 times k minus 3. Now I can do some simplifications here. On this term, I have, this is one factor times another factor, one factor times another factor, so I can cancel those 2's. Now I don't want to rewrite all that stuff again, so what I'm going to do is just erase them. Now you've seen what I've done. We've canceled them out, so they've gone. They don't go to 0, they turn into factors of 1, and 1 are trivial factors. We don't bother to write those. So your job is to factor, I guess I'd go back to yellow. You need to factor k squared plus 4k plus 3, which if you're really good at this, you can immediately say that's k plus 1 times k plus 3. So this time I won't leave you in the dark. Let's do k squared plus, that's supposed to be 2k there. There we go. Let's do 2k squared plus 9k plus 7. As I could only factor out a 2, which leads the leading term to be 2k squared. And I mentioned that's going to be the one that's going to probably require you to do this. So 2k squared. This is 7, 9k. It's not so bad because since the leading coefficient on the leading term is 2, I only have one choice, 2k and k. Now I have a choice as to which one I want to put first and which one to put second. That doesn't matter. 7's prime. So I've got to figure out, is this whole thing prime? Is that 9k? 7? 18? Do I have that 2 as 9? Did I write this down wrong? Well, 7 I can do, that's a positive 9. Yes, 2k minus that. So I'm going to do 7 here. You all are screaming at me, aren't you? When you see it, and sometimes you don't. So 2k plus 7k is 9k. 1 times 7 is 7. 2k times k is 2k squared. So this factors into 2k plus 7, k plus 1. So now I am going to write it down. And on the next step, I'm just going to note that 2k squared plus 9k plus 7 is equal to 2k plus 7, k plus 1. And I'm just going to write it. I'm tired of writing things, people. I'm sure you all are quite ready to end this semester too, and we're getting close. So I'm going to write k squared plus 4k plus 3 as its factorization, because remember the first term of division doesn't change. There's something I can cancel. I'm going to do all my cancellations before I do the division. So now I'm going to write 2k squared plus 9k plus 7 in its factored form. 2k plus 7 k plus 1 over k minus 3. Now let's get some more room. So what I'm going to do here is I'm going to cancel out the k plus 3 terms and then start my division. That's the only thing I can do. So don't try to cancel across the division sign, because you can't cancel across the division sign. No canceling across division sign. Wait to change from to multiplication. Just a reminder for you. A little finger around your string, or string around your finger. So I have 2 times k plus 1. The first term in division doesn't change, and just a k minus 3 that survives there. Now I'm going to change my division to a multiplication sign and write now the reciprocal of my second term. So that's going to give me k minus 3 over 2k plus 7, k plus 1. Now that I've changed it into multiplication, I can start canceling, because you can cancel across the multiplication sign. K plus 1, there's 1 here and there's 1 here. K minus 3, there's 1 here and 1 here. I've canceled everything that can be canceled. So my numerator now, the only thing that survives on my top line is a 2. And the only thing that survived on my bottom line is a 2k plus 7, which again I encourage you to write in parentheses so you're not tempted to try to somehow cancel out those 2's. A lot more to do. Multiply or divide as indicated. Working this out with examples. So we've got 3a. We have x squared plus 5x plus 6. At least these are polynomials, degree 2, trinomials to be specific, with the leading term 1. Those are called monic polynomials. X squared plus 8x over, what is that, x squared minus 4x plus 3. Okay. So the first thing we want to do is we want to factor these things. So the first factorization is going to be x plus 3, x plus 2. And the bottom is x plus 3 times x plus 8. Yes, I am cheating. But if you think about it, all you're doing is you're looking for two numbers that multiplied together give me 24, and when I add them together, I get 11. That's the trick. I'm multiplying, looking for two numbers. This is always true when you do it by when the leading term is 1. Find two numbers multiplied together that give me 6, and added together give me 5. So that's 3 and 2. Two numbers that multiplied together give me 24, and added together give me 11. So that's 3 and 8. Now this is multiplication. Here I'm going to factor out my x term, because that's my greatest common factor. And down here, two terms multiplied together that gives me minus 3, and added together gives me minus 4. There's only one thing that will work that way. That's minus 1 and minus 3. Okay, I've got a multiplication there. I can cancel across the multiplication sign. Is there any x plus? Oh yeah, right underneath of it, there's an x plus 3. It's gone. Is there any x plus 2's down there? No. So x is down there, but there is an x plus 8, so that cancels. So what remains is our product. Remember, when you multiply two things, you get a product. So that's x times x plus 2. And down here, what remains is x minus 1, x minus 3. Here is the thing, leave always in factored form. Again, you do all of that work to factor it. Don't undo it. It's almost always better to have something in factored form. In factored form, it's really easy for me to know what values make the denominator 0. Well, the denominator, if x is 1, 1 minus 1 is 0. And if x is 3, 3 minus 3 is 0. So the values that have to be excluded are x is equal to 1 and x is equal to positive 3. Much easier once factored. Okay, one more, I believe. It wasn't too bad, but this one's a division. But again, remember always that division is one step away from multiplication. It always has been. As a matter of fact, when you divide by 6, you're multiplying by 1/6. That's just what it is. The only thing about division that you have to worry about, that you don't have to worry about with multiplication, is dividing by 0. You can always multiply by 0, but you cannot divide by 0. And that's it. So this is 3b. So we have y squared minus 11y plus 30. All of it is over y squared minus 36. Now I hope you're already thinking that y squared minus 36 is the same as y squared minus 6 squared. Then we have my division, and I'm not going to change that into multiplication until I've literally factored everything and simplified both sides. So now let's just get us all the room we need. So factoring the top, I need two numbers multiplied together that give me 30, and added together get me minus 11. So clearly those factors have to both be negative. So 10 and minus 3 isn't going to work. Minus 15 and minus 2 isn't going to work. What about minus 6 and minus 5? That's going to work. Now you all can do the tic-tac-toe method exactly as you want. I just wanted to do it in my head, and when you get good, you realize that's all you're doing with the tic-tac-toe method when you have the leading term equal to 1. As a matter of fact, if the leading term were always equal to 1, I would have never taught you the tic-tac-toe method. The tic-tac-toe method works, or table method or whatever, when the leading, much better when the leading term is not 1. So y squared minus 36 is y squared minus 6. So that's y minus 6, y plus 6. Great, I already see something I can factor before I start trying to divide. Y squared minus 9, well, that's the same thing as y squared minus 3 squared, which is y minus 3, y plus 3. And y squared minus 3y minus 18. I need two numbers multiplied together that give me minus 18, and added together give me minus 3. So it's going to be 8 minus 6, 8 plus 3. Now I'm not ready to change the division sign just yet. I'm going to cancel out any terms I can. Remember, I cannot, I guess it would help if I made these y's, right? I cannot cancel across the division sign. But here I can indeed cancel out my y plus 3 terms. So this gives me, I'm set to divide, so I have y minus 5 over y plus 6. Now I'm getting ready to change the division into the multiplication, and the y minus 6 on the bottom comes up top, and the y minus 3 goes on bottom.